Hey everyone, this is Derek, and in this video we're looking at average rate of change based on a table, graph, and then we'll also do a verbal description. So average rate of change it goes with slope. If I have a function, for instance, let's say I am driving to Spokane, so forget about math for a second, driving to Spokane, and I'm going to drive, about 280 miles in about 4 hours. My average rate of change then would be 70 miles per hour. That would be what I would be averaging in terms of my rate. But if I look down at my speedometer, in general, when I'm going through Bellevue, you don't get to go 70. And in general, when you're near Ephrata, you're probably doing closer to 85, right? So my instantaneous rate of change is going to be different at all those instances along the trip, but overall I'm averaging 70. So if we're thinking of that graphically, my trip, my actual speed would be, or my distance covered would be all over the place, but what I'm looking for is, on average, if I started from here and I ended here, what did I do on average, not at specific points? So it's a way to compare given intervals. This also ends up kind of leading to all of first quarter calculus, so it's actually a really important idea. And if this is a business class, then this would lead to, in terms of 148, kind of the whole first half of the course is based on this idea. Okay, so average rate of change of a function between A and B is equivalent to the slope of the line between the points. That's what we're just talking about. And so here's some notation for this change in Y over change in X. We can think of this as an A, we're putting in some point A and some point B and finding the average rate of change between those points. So instead of a Y2, I would put in an F of B, and I put in B, I get out F of B. So this is like my old X1, Y, those would be my 2's actually for how we would usually label that. And then this would be my old X1, Y1. So this is like X and X2. So I put in X2, I get out of Y2. I put in X1, I get out of Y1. But now we're putting in A, getting out F of A, putting in B, getting out F of B. So that's what this is showing right here. It's just like our Y2 minus Y1. Another way that you'll see it, if you go on to 148, I think that textbook uses this notation, which I actually kind of like a little bit better than the A's and the B's, because it's emphasizing, here's your change in X, X2 minus X1, same as our slope. And then this is just saying the function evaluated at X2, which is the same thing as Y. Function evaluated at X1, same thing as the Y. So anyhow, this is your average rate of change in terms of a formula. In terms of a graph, it's the slope of the line, so it's that delta Y over delta X. Same exact thing, just kind of graphically. So let's see how that looks in terms of some actual questions. Okay, for this question, the following chart shows overdose deaths in the United States between these 2 years, and then we are trying to figure out the average rate of change between 2014 and 2017. So, looking here, 2014 went with this number, 47,055, and then 2017 goes with this, 70,237. And so there's my ordered pair, and then I'm just going to do my change in Y over my change in X. And so in this case, it's just like finding slope. So, okay, I just set up my slope equation here, which we could also think of as average rate of change, and I'll use that as an abbreviation just because it's a lot to write. And if we do that math, then we'll get 23,182 over 3, and then I rounded to the nearest person. But so this would be 7727, so 7,727 deaths per year. And so these are the actual numbers of deaths due to overdose in the United States per year. And then what this says is that on those 3 years, the number of overdoses was increasing by this number of deaths per year. Question 2, this one is mark the 2 points on the graph that are needed to calculate the average rate of change over the interval -4 to -1. So when x is -4, that would be right there. And when x is -1, that would be right there. Connect the points of the line segment. When you go to do this on the computer, it doesn't want you to draw all the way through. It's super annoying. It just wants you to do that. And then find the average rate of change over that interval. So, okay, I'm gonna do it 2 ways. I'm gonna go, well, this point, right? This would be x is -4, y is 4. This point is -1, 1. So I could do this as, just basically average rate of change, which is slope. 1 minus 4 over -1 minus a -4, giving me -3. And then this, so many signs. Okay, so -1 plus 4 would make 3, and that makes -1. So that was the hard way to find the average rate of change. I could also just kind of look at my graph right here and go, hey, what's going on? So it's going down 3. That would be negative, right? Because we're heading negative direction. And then it's going 3, and so then my change in y, change in x, -3, oops, throw an equals in there, 3. So there's the exact same -1, and you can see it right off the graph. So no reason to do all this on that problem, but just to kind of show how those two things do tie together, you end up with the same -3, 3, either way. And then this one is the exact same idea, just from a verbal description. So the 3rd month this year, you have $478 saved. On the 8th month this year, you have that much saved. What is your savings rate? So we're not saying that this is the amount you put in every month. This is the amount you averaged every month, right? So maybe, April, you got your tax return, dumped in a little bit more. So that's an average rate of change. It doesn't tell us that that's exactly what happened each month. These points we're going to write out, we're going to have years be our input and dollars be our output. So we don't have dollars per month. And same thing here, so we would have 8 and there. And now we're just saying average rate of change. And so just our kind of our y2, y1, x2, x1 again, or change in y, change in x. And then this is dollars, right? And then this is months in terms of our units. And then I threw that in a calculator, got 640 over 5. And so that would be $128. Let me write it this way, dollars per month is what we'd be putting away.